Welcome to the Eclipse Research Community presentation. I'm very proud to have this presentation again this year, so it's for the second time. We are involved in the research project now since 2014, and last year we finished our first project, EPP4MC. And so we are involved in research projects for different reasons that I try to list here. So sustainability reason initially, so people really would like to have our project sustainable after the end of the duration of their project. Some guidance about how we manage open source projects. Our expertise in community building, it's also something that for them it's very important, how we can help them to make sustainable is to create a community around their project. Of course, they want to be able to reach the Eclipse ecosystem for different reasons. That I will not have time to enumerate that, but you will see through different projects how it happens, and open collaboration as well. So here you have the list of the current projects, and these guys also, GMOC is part of our research consortium that we have in Eclipse, and STAMP is a project invited to this event. So it will be very quick. So these guys have 7 presentations to present, so I will not present, but we have 7 speakers. They only have 4 minutes, and so if you have any questions, please go to the research booth. We have this here, we're a huge research booth, so you should not be able to miss it. And you will meet the speakers, and they will be happy to answer to your question at this point. So let's start with the first one with Davide of PlusMiner.
Okay. Good morning, everyone. I'm Davide Di Ruscio from the University of L'Aquila, Italy. I'm the technical coordinator of the CrossMiner project. And just to give an overview about what the project is about. So the context. The context is that you want to develop new software systems by reusing and combining existing open source components. And you know that when you want to do that, you have a number of issues that you have to deal with. So you have to search for candidate components. You have to evaluate among all the possible components that you have, which one can be used that can fit your goal. How understand also how to use the selected components, and also you want to monitor the selected components because you want to see, for instance, if the selected components somehow the quality of these components go down because the community is reducing the support around the components, etc., etc. So you know, when we want to select a use of open source components, there are several tasks that you have to deal with. So you have to consider different information sources and heterogeneous sources of information, right? And in this respect, CrossMiner is essentially in between the developers and between all the sources of information, because essentially what CrossMiner does is it performs a different analysis on source code, on communication channels by means of natural language processing techniques, also analyze the configuration codes of the open source components, and try also to infer additional information, additional knowledge, for instance, about similar projects by means of some machine learning techniques. And all this information then will be given to the developers by means of an advanced IDE, so an Eclipse-based IDE. So all the information will be provided, and all developers will be supported by means of an Eclipse-based IDE in order to support the development activities. So essentially, CrossMiner can be seen as a real recommendation system, because essentially what happens is that you do some data preprocessing. So the system analyzes and preprocesses all the information coming from different sources of information. And then essentially we have the developer ID that is used for querying the knowledge base. So for instance, okay, I want to retrieve some library for implementing some JSON-based, to parse JSON documents, for instance. Which library I could use. So the query is sent to the knowledge base that according to the data that has been managed, then the knowledge base answers with corresponding recommendations. So that's the main idea. CrossMiner will be, we have already the Eclipse Scala project. This means that we will, after the summer and immediately after the first European review, we'll work on releasing the initial contribution of the cross-miner projects. So that's all on my side. If you need some more information, again, we are in the research booth.
Okay, hello everyone. I'm Benoît Comamal, professor at the University of Toulouse, and I represent you GMOC, which is all about scientific grand challenge related to the globalization of modeling languages. So what we mean by globalization of modeling languages is designing, implementing, and relating different heterogeneous modeling languages in order to support their use in a coordinated way through the development process. So this is what we call the globalization of modeling languages, and we started in 2012 what we call the GMOC initiative, which is a very informal initiative that gathers together both practitioners and researchers interested by the grand challenge of the globalization of modeling languages. So basically sharing experiences, solutions, and problems related to this grand challenge. And more recently, in 2017, we sustained this initiative in terms of a research consortium at Eclipse, whose main objective was to give a structure to this initiative and to be sure that we can sustain this initiative beyond some research projects funded by Europe or some national agencies. And in the context of this research consortium, we created the first Eclipse project, which is the Eclipse GMOC Studio project. And the main objective is to sustain a research platform on which all the partners can experiment, build prototypes, define some demonstrators related to the grand challenge of the globalization of modeling languages. So what is the GMOC Studio? This is an Eclipse package on top of EMF and all the ecosystem of EMF, and where we provide two perspectives. The first one is a language workbench, where you can design, implement your modeling languages and to define some relationships between these modeling languages. And as soon as you design your modeling languages in the language workbench, this is automatically deployed in the modeling workbench, where you can use these different modeling languages in order to edit your models, to execute your models, simulate your models, and having some concurrent execution of heterogeneous models. So if you want a demo of the GMOC Studio, we are on the research booth of Eclipse, and there is Didier Bostijek, who is a software engineer at Inuia, that can explain you the different tools that are available in the GMOC Studio and provide you a demo if you want. So please come to the research booth for having a demo. Thank you so much.
Hello, my name is Jotsumer Martin. I come from Universidad Politécnica de Madrid, and I am the scientific and technical lead of PDP4E, which is short for Privacy and Data Protection for Engineers. So this graph represents the number of queries for data protection in the last 5 years in Google. You can see there's a peak to the right in the last few months. And do you know what's the reason? What's happening with data protection? This. GDPR. Maybe you have received a lot of emails about GDPR, the General Data Protection Regulation, which has come into force last May. That's a European regulation, but with a global reach. And maybe you are thinking whether this is relevant for engineers, whether this is relevant to developers. The answer is yes. It's relevant. This isn't something that is said by me, but there are several magazines, blogs, IEEE Spectrum, which is the largest magazine for electrical engineers in the world, which say that, yeah, you need to take into account GDPR and privacy and data protection. This is not just stuff for lawyers, but also for engineers. But unfortunately, engineers cannot deal with the large, big, thick book of the law. What engineers want is to deal with models, with requirements, with backlogs, with assurance projects with terms we engineers are used to dealing with. And from this challenge, the PDP4E project comes. We want to endow engineers with privacy and data protection tools that are aligned to their mindset. We know that privacy experts will always be necessary, but we also think that engineers will need to deal with privacy and data protection in their daily activities, same as what they currently do with security. They're also security experts, but everybody needs to have at least a hint of knowledge about security. And that's why we are proposing to introduce privacy and data protection aspects into the tools and the methods that engineers are already using. We do not want to create new tools for privacy and data protection for engineers. We want to integrate into existent methods, into existent disciplines, such as requirements engineering, such as model-driven engineering, model-driven design, such as software assurance, and such as risk management. We are indeed integrating the results of the project into existing Eclipse tools, into Papyrus for requirements engineering and for modeling and design, and into OpenCert, which will be presented just next because it's also a result of previous European projects, for software assurance, in this case for privacy assurance. This is the main goal of the project, providing those methods and those tools, but we also want to create a community that joins the efforts from privacy experts and engineers and developers overall, so that we can share the knowledge and we can advance in the knowledge of privacy engineering and the practice of privacy engineering by developers and engineers overall. We are there at the booth. The project has just started, so we do not have just results, but we have a lot of questions that we would like to have answers from you on how you approach privacy. What do you know about privacy? So we would be glad if you could drop by the booth and talk with us for a while. Thank you.
Hello everyone, my name is Atif, and I will provide an overview of the MAS project and some of the approaches in the project. The idea with the MAS project is to develop an integrated and holistic approach and supporting tools for assurance and certification of cyber physical systems. The project aims to produce 3 tangible outcomes: the MAS reference tool architecture, the Open MAS tool platform, and the Open MAS community. Besides, the approach is proposed by the previous EU project, in particular OpenCOAST and SafeCert. Many tools such as Eclipse Process Framework Composer, Chess, and OpenCert have been integrated and extended in the MAS platform. The MAS project is constituted of 4 scientific and technical objectives. The first objective is architecture-driven assurance, which provides support for system component specification in accordance with the domain best practices. It covers system architecture modeling for assurance and architectural patterns for assurance. The second objective is multi-concern assurance, which is devoted towards the development of assurance cases, co-assessment, and contract-based assurance, which addresses multiple system characteristics, mainly safety and security, but also other dependability-related aspects such as reliability, availability, and robustness. The third objective is seamless interoperability. It is ensured between the tools used for modeling, analysis, and development of cyber physical systems. The fourth objective is cross and inter-domain reuse. I will provide the overview in the further slides for this specific objective. The MAS vision for compliance management is development and integration of 4 complementary methods, in particular mapping tables generation of argumentation about compliance, automated compliance checking, and ontology-based mappings. For compliance proof, we use the rigorous tool, which is compliance checker for the processes. We have implemented the generation of process and product based argumentation. The process based argumentation generation is triggered from the EPF composer, while the product argumentation generation is triggered from the chess. The argumentation fragment visualizations is its results are visualized at the assurance case editor of OpenSat. The reuse function supports the semantic mapping of semantic mapping for the standards. It is, however, required to represent the standard terminology, relationships, and patterns, if any, in accordance with the OSL's knowledge management methodology. The queries are executed to retrieve the results for the specific standard. The reuse assistance function is developed on top of reuse discovery to help users in understanding whether reuse is feasible and which further activities are required to justify compliance in new scenario. We have also implemented the approach for process, product, and assurance case variability management. Besides that, the goal of the MAS is to support the the ripple effects, the impacts on processes as well as assurance cases in response to the product requirement changes. For example, for the variability management of processes, the integration between Eclipse Process Framework Composer and BVR tool has been achieved. The BVR tool is also the result of a European project, and its simplification and enhancement of the common variability language standard. Many thanks for your attention. I will be available at the booth for answering any questions. Thank you.
Hello everyone, I'm Robert from Dortmund University of Applied Sciences and Arts in Germany, and I would like to introduce to you some basics of our Eclipse Kuksa project. So the challenge here is that the IoT community in Eclipse is pretty huge. However, as soon as you want to reuse such technologies and apply them to the automotive domain, there are certain constraints and issues, for example, security demands or reliability demands, so that such technologies need to be adapted. So this is something we focus on Eclipse Kuksa, as well as providing a whole platform. Actually, it's an ecosystem consisting of 3 platforms, and this will allow programmers to develop applications for the vehicle, and the vehicle will provide such applications, for example, for an HMI, a human-machine interface, and you're also able to program cloud applications. So, and all this should be based on standards, on open source software, and be supported by a large developer community. And actually, why do we need it is, well, vehicle owners can thereby have the possibility to install new applications to the vehicles, similar to everybody does it on the smartphone. And also, you can actually also buy new features like an advanced driver assistance systems and apply it to your vehicle. This is something that is in focus. But also some things that the vehicle owners do not directly see, and this is the whole backend of the architecture, like the backend of the cloud platform, the operating system of the in-vehicle components, and of course all these demands that I already mentioned. And this is our view of how the ecosystem looks like. So we basically have a cloud platform, and here we already show the Eclipse IoT technologies that we want to use there. For example, the Hono, Eclipse Hono is for the cloud instance, for the backend. Keycloak is for supporting security aspects, and so on. On the other hand, there is the in-vehicle platform, and we made some efforts for identifying the most appropriate approach, and we found out that automotive-grade Linux is most appropriate for our intents. And in addition to this, we also have an IDE. Our current approach is that we use Eclipse She for that. There will be also a couple of other presentation about Eclipse She, but I would not go into detail, just as a cloud-based and Docker-based platform to have your IDE in a browser, basically. Now, the whole Eclipse Kuksa comes from the AppStackle project. It's an international funded European project. It lasts 3 years. It started in January last year, and it consists of 20 partners across 4 countries and, well, has some budget and personals. Now, this is also a view of the repositories, more or less. So there are a lot of cloud technologies that we want to use. Then there are a lot of vehicle technologies that we use and that we use in order to build our AGILE adapted images and SDKs. We can also build for target-specific applications, for example, a rover that we developed. And from our Eclipse She instance, we can develop specific applications for the in-vehicle platform and also cloud services on the other side. This is my final slide. It just presents you the roadmap. So where we are around here. We started in 2017 beginning. We already had a hackathon at the Bosch Connected Experience. We made a platform study that I mentioned. We're also thinking about stuff that we, for a follow-up project. As you can see here, we just recently had our initial contribution to Eclipse finished. So the Eclipse proposal is through and the initial contribution is through. That means that our very initial code base is already available. It's consisting of 5 GitHub repositories. And now soon, all the CQs will be started to add the third-party software that we use in the project and to, of course, also incorporate new developments that we are focusing in the project. And by end of 2019, end of next year, we will have our final release, Kuksa 1.0, and on the timeline there is also like having a HMI demonstrator ready by December of this year, and over-the-air update mechanisms. We are already working on that, and we are focusing on having them available next year. That's more or less it for the basics. However, there will be just right subsequent to this session dedicated talk to Eclipse Kuksa in the spot room. So I would I would like if you join us with a colleague of mine from Bosch Software Innovations. We will have a talk in the spot room, so feel free to join us there, or of course you can join us at the research booth as well. So thank you very much.
Hello, I'm Krief from Fondazione Bruno Kessler in Italy, and I'm the technical coordinator of the AGILE project, which is, AGILE is the European project, 3 years, 17 partners, and based on it we have the Eclipse AGILE project, which we are doing the initial contribution now in the IoT, Eclipse IoT framework. So what is Eclipse AGILE about? It is about part of the IoT ecosystem. It's about the gateway. The gateway is fundamental part of the IoT ecosystem. Of course, things are important. The cloud services are important, but once you start to build an IoT system, you will realize that you will have the gateway and you will have lots of challenges on deciding what to choose, what technologies to choose, and how to make them communicate with the things and communicate with the gateway. So these are some of the challenges that we are addressing, and I would like to focus on this one here, which is the ease of use for developers to develop, prototype, and then develop and then scale IoT applications. For this we are devising an architecture which is focused on extensibility and adaptability to different verticals. We are focusing on applications which are putting the gateway in the center, so putting more logic to the gateway, having an edge component with intelligence, and of course, it's being a gateway, it has a number of interoperability challenges that it has to address. So, as a project, we are, as I said, we are focusing on the gateway, and for the gateway, we are trying to provide a full solution, build a full solution and build an ecosystem around it. So we start from the hardware as a project. We build a maker's gateway version and an industrial gateway version, and we are actually providing for the maker's gateway open hardware, and we are also, so we are open also there. And then we build a software stack which is based on, which is open sourced from bottom to up. Starting from the operating system, Yocto-based operating system, and then we are having Docker-based containerizations on the gateway itself, trying to streamline that enough so that everything fits. And then we have components built for building IoT gateways with connectivity options, exposing a well-defined API, and then helping actually application development on top of that. So we are helping rapid prototyping by embedding Node-Z on the gateway itself. And then on top of that, being a European project, we have a number of ecosystem building activities, also thanks to Eclipse, building different applications on different verticals using this gateway, and now having 16 partners building applications using this gateway. So, yeah. So this is the architecture. As I said, in this when devising such a gateway which is modular and adaptable, we had to focus a lot on the architecture itself. So devising an architecture in which you can customize well, and it's based on Docker-based containerization. So each module is a Docker container, and we are streamlining that. So right side, rapid prototyping with AGILE is something we are working on. As I said, you could get the maker's version of the gateway. It's based on the Raspberry Pi with an extension shield that we are developing, and add radio communication modules, download and install software. You can get a gateway for which you have already a management interface. You can connect it to devices and manage the gateway. Then the gateway itself already has embedded storage facilities. You can already visualize data. So this is all steps which are helping in prototyping. And then we are embedding a graphical application development environment with which you can fastly prototype applications on different domains. So building components for all these, building and reusing components to support all these. And that would be just like prototyping, but then obviously need comes to scale this. And for this we are building an industrial grade gateway on which you can move your application. You have different deployment options. We are working on fleet management to manage a fleet of gateways from a cloud platform. Communication modules to cover the different types of IoT devices that are around and that are upcoming. And also facilitating adding new communication adapters. Cloud integration with pushing data to cloud. And then application development also this way with rapid prototyping, but you can also deploy applications using Docker on the gateway, so that using the APIs of the gateway software itself. So this is, in a nutshell, AGILE, and please come to our booth and visit us and if you have questions. Thank you very much.
So hello, I'm Caroline Landry. I'm the technical manager of the STAMP project. STAMP stands for Software Testing Amplification. And so it's a European project with 4 academic partners and 4 companies and 1 open source consortium. So I'm the technical leader, and Benoit Baudry from KTH is the scientific coordinator of the project. So what is STAMP? So STAMP stands for Software Testing Amplification, and the idea is not generating tests from anything, but using the existing assets like source code and test routes to generate new tests. So in different steps of the life cycle. So in the context of DevOps, the automation is the key now, and there is some painful tasks like coding unit test or testing configuration, different configuration. Sorry. And so the last is when you deploy software and you have a crash. So analyzes the traces and the log to reproduce the crash is also handmade. So in this context, we have several tools developed in the context of the project. So for unit testings, first are Despot and Descartes. So they are working both on the source code and on the test suite. So Descartes is a tool that allow you to score your test suite, so to evaluate your test suite, and using mutation testing techniques. And Despot use Descartes to score your test suite, and then you, based on it, it also allows you to generate either new assertion, new test, or new test cases. So, second point is configuration testing. Usually it's really painful when you want to test your software to introduce some variability in your configuration, like version of your browser or kind of browser, Java version, Linux version, or whatever. And so the idea here is to use existing configuration of the software to generate a new configuration. So everything is based on Docker and Docker files, and so to automatically generate new Docker images and to allow you to execute the same test suite in different configurations automatically, of course. The keyword is automation here. And so the last thing is when your software is deployed and you have a crash. So usually it's not so easy to reproduce the crash when you are only logs. And so the idea is to have the stack trace, a Java stack trace, and to generate a new test case that reproduces the crash automatically. So that's mainly the feature of the STEM project. And so we have, I think I forgot, of course, everything is open source. So we have a GitHub. We can find the tools and test them. And we also have a website. So it's stem-project.eu. And you can have a lot of information of it, including scientific questions, etc. So I'm actually not on the research booth. I'm just behind, just next door. It's the OW2 booth, the same area, not so far. So thank you.
Thank you. For joining this meet and greet meeting, and I hope we will see you very soon at the booth. Have a great conference. Thank you.